Hey guys, welcome to another video. So today, another video in the final question series. Today's question comes from the Extension 2 syllabus from Sydney Girls, right? Last question in their 2024 trial paper. So, yeah, with all past papers in 4 unit, the last question is generally quite hard, right? This question today, it's not ridiculously hard, but the marks, 12 marks, right? 12 marks out of 100. Obviously, if you couldn't do this question or parts of it, not in good shape, right? So make sure you can understand questions like this so you can have a go at it when it's your trials. Guys, before we begin, before we dive in, as always, if you like these videos, subscribe to your channel, tell your friends, and then like the video at the end. Guys, let's dive right in. So it's a long one, so let's take our time, read through the questions, and see how we go. So first part, show that. Not too bad. Feels like common denominator stuff. And prove recurrence. Okay, 30 marks. Yeah, that's about right. Sorry, let that prove that. Sorry. Yep. Okay, then in part 2, okay, unwind the recurrence. Now, you have to be able to do that, right? Very common. I've seen this a lot of times now. Just make sure you can unwind a recurrence expression, right? Wow, okay, what's happening here? Show that, okay, there's a recurrence piece, right? Okay, and I'm given that. Okay, cool. Yep. And then sign is defined as that. Use that, show this. Okay. Yeah, it's at this point where I'm like, okay, I hope that the part above provide enough guidance for me to do these parts, right? That's really all you can ask. So let's do it systematically. Let's go up to part 1. Let's get cracking. So part 1 over here. All right, I'll have the questions up here so I don't have to always refer to it. Okay. Part 1. So show that. So left-hand side equals to x to the power 2n minus 1 all over square root. I think it's just common denominator. Maybe you guys can pause the video, do it yourself, and yeah, see if it's right. 2n plus 1. Let's see, root 1 minus x squared. Okay. I'm just going to common denominator. Is that right? So it feels like common denominator and maybe factorize the top or something like that. Generally the way to go. So x 2n minus 1 minus x 2n plus 1. Okay. It's going to factorize, maybe simplify a bit. I think that'll work. Now, what am I trying to prove it to? Okay, I want the square root. Okay, cool. I think I can get that. I get that, because if I factorize x 2n minus 1 out, right, I get 1 minus x squared on top, and we know that this cancels out with this to leave root 1 minus x squared, which is a right-hand side. Okay, cool, done. All right, 1 minus x squared, which is right-hand side. Perfect. That was how many marks is that? 1 mark? Yep, cool. All right, now I'm going to prove recurrence. Okay. All right, okay. Now, just to identify some stuff, right? So I can see, right, if they're asking me to prove recurrence, see that definition of recurrence there? Or that definition of I2n minus 1, that looks exactly the same as that. So if I put the limits on that, that would be I2n minus 1, and that would be I2n plus 1. So if I just integrate both sides and then maybe do by parts on this side, I think I should be able to do it. Well, it tells me to use by parts. Okay. All right. Let's go there. So part 2. So now I'm gonna integrate part 1. And you get like integral of 0, 1, x 2n minus 1 over square root minus x squared dx minus integral 0 to 1 x 2n minus 1 or plus 1 over root 1 minus x squared dx and equals to integral 0, 1 of x to n minus 1 root minus x squared dx. All right. So just to be absolutely clear, right? Like I said before, this part here, right, and this part here is given. Sorry, the question tells me, right? It defines this to be I 2n minus 1. That must be I 2n plus 1. Right? So if I can find an expression here, then maybe I can make it work, right? So therefore, if I scroll over here, too much. Issues by parts, right? So let's see. Now, by parts basically says I want to let dv be the thing that I can integrate quite easily. So it feels like maybe this times this is dv, and maybe let this be u. All right, let's check that. Yep, I think that's right. So off to the side, I'm just going to go let u equal to square root 1 minus x squared, which means du equals to bring down the half minus 1 to the power. I'm going to show a bit of workout. Multiplied by minus 2x dx. And so therefore du equals to 2's cancel out, so it becomes minus dx. No, yep, no, minus x over root minus x squared dx. Okay. And then dv equals to, what's it, x 2n minus 1 dx. I integrated that, add 1 to the power, divide by new power. Yep. Let me just check that. Yep, that math looks right. So then over here, I'll say that therefore I 2n minus 1 minus I 2n plus 1 equals 2 now. Limit uv holds v. V was that, okay. So it'll be x 2n square root 1 minus x squared over 2n 1 0. Now if I sub 1 in, sub 0 in, okay, that's 0, good. That goes away. Minus that times that, so that's a plus because of this guy, right? That's a plus. Take out the constants, which is 1 on 2n. Integral 1 0. Now I'm a bit squashed, so let me move this down a peg. Okay. This guy times this guy. Now the top there would be x 2n plus 1. Bottom 1 minus x squared. Guys, and when you see it, right, that there is the same as I 2n plus 1. Perfect. Yeah. And also this guy here, the limit goes away, right? 0, because when you sub 1 in, it's 0. When you sub 0 in, 0. Okay. So what I'm left with, and hopefully this is going to give me the answer, is I 2n minus 1 plus, also minus I 2n plus 1 equals to 1 on 2n times I 2n plus 1. So what am I trying to make the subject 2n plus 1? So I'm going to bring this guy over, factorize. So I 2n minus 1 equals to I 2n plus 1 factorize like 1 on 2n plus 1, which equals to a common denominator. It'll be 2n plus 1 on 2n. If I divide that over for I 2n plus 1 equals to 2n on 2n plus 1 I 2n plus 1. Guys, 3 marks, right? I mean, I don't think that was particularly hard, right? Like, that's very sort of textbook by parts recurrence. Okay. All right. We're 4 marks down out of 12. Let's keep going now. I'll go on to the next one. I'll probably make a copy. Let's read. So part 3. Okay, I just need to unwind the recurrence to prove that. Okay, I'll show you what I mean by that, right? So no. Hopefully it's not too bad, okay, when I unwind it or unroll it, right? So from sorry, it is part 3. From part 2, I got that this guy equals to 2n plus 1 I 2n minus 1. Okay. I'm going to slowly unwind this guy, right? So I know that then that equals to 2n plus 1. Now, when that was 2n plus 1, this was 2n. So this must be, when that's 2n minus 1, this must be 2n minus 2. And this should be exactly the same. Right? And then it'll be 2 lower, so 2n minus 3. Right? And then I'll unwind this guy as well. So sub in the recurrence formula there. So it becomes 2n plus 1. And then you start developing a pattern, right? You just go 2n minus 2, 2n minus 1, and then what that 2n minus 4, right? Over 2n minus 3 by 2n minus 5, right? Now you can sort of see that the top is slowly decreasing by 2, and so is the bottom, right? But it's sort of mismatched. The bottom is like 1 bigger, right? So then I'm going to use ... right? Right? That equals 2. I'm just going to be a little lazy and just copy that. I'll delete the end part and go ... Right, so sooner or later, the even numbers on top, the bigger odd numbers on the bottom, so sort of reach like 4 on 5, maybe 2 on 3, and I suspect now at the very end there, let me just check. Pretty sure it's right. That it's 2 on 3, and then now when that occurs, always look at the I. So when that's 2, oops, wrong color. When that's 2, right? That's like saying 2n, right? So 2n equals to 2's plus 1, is it? 2, no, sorry. So let's see. So when that's 2n plus 1, this is 2n. Yep. So when this is 2n plus 1, this is n. So when this is 2n plus 1, so right now that's n equals to, when that's 2 times 1, I3. This is I3, right? Okay. Yep. So this is I3. So then we have one final I1 to go, right? Yep. And I find I1 and then sub it in, right? Cool. So now let's find I1. Yep. Cool. So I1 is when the integral, let's see, x to the power of 2n minus 1, so that's x, over square root 1 minus x squared dx. Guys, we can use reverse chain rule for that, right? So I need the derivative, which is negative there, negative. Oh no, I need negative 2, right? Negative 2 times by negative, oh sorry, don't need anything times, negative half, negative 2x, okay, cool. So then that becomes negative half multiplied by the function to the power of negative half, so it'd be like that plus 1, so it'd be like root 1 minus x squared over half the limit 1 and 0. Yeah, that cancels out, and I get negative. Sub 1 in is 0. Sub 0 in is 1. So 1, I believe. Is that right? Perfect. Right. So sub 1 in. Therefore, now what you're going to get, if I combine them all together, you get 2n. I'll factorize for each one of these. I'm going to factorize a 2 out, right? So then you get 2 times n minus 1 times 2n minus 2 times 2 times 2 times 2 times 1. Right? And at the bottom here, what do I get? I'm just going to leave it. In fact, I'm going to reverse the order. 1 times 3 times 5 times 2n minus 1, 2n plus 1. Right? Now you can see on the top, you got 2 multiplied by itself n times, right? Yeah, n times. So these guys must be 2 to the power of n. And then you have a factorial, right? N factorial there. You can sort of see that's clear. So let's go. That's n factorial. Yeah, on top. So therefore, right, I 2n plus 1 equals to the power of n factorial all over 1 times 3 times 5 times 2n plus 1. And that's what I want to prove. Yeah, so to unwind a recurrence formula, right, you basically sub it in a few times, get the pattern, and then make sure there's an endpoint. In this case, I1 in pink, find I1, sub it back in. This case is 1, so it doesn't make a difference. And then see if there's any patterns. Normally, when you do this, you'll get things like factorials and stuff, right? Guys, that was 2 marks. All right, doing well. Let's see. Now, the next one looks a little bit heavy, so let me just have a quick read of that. Show that this equals to that, okay? Where, okay, actually that looks exactly, or that looks like the reciprocal, is it, of what we just proved up here? Okay, all right, okay. That might be useful, so actually I'll do that in blue. Yeah, because it looks like, where is that? That's over here. Oh, but we're given that, so maybe I'll just use this. We'll use this one instead. Okay. Sorry. Use this one instead. Yeah, so I'm going to sub this into here. Right. And then, okay, that looks like I 2n plus 1, which I think I can sub this guy in, right? So if I sub the blue, because the beauty about subbing in the blue and the pink is that they sort of cancel out, and I'm left with, yeah, okay, easy. I think that's a really easy question. It's just subbing in stuff. It just looks complicated, right? Looks mighty scary, but that I think it's a puppy dog. All right, cool. Let's have a look. So part 4, right? So I'll go left-hand side equals to 0, 1. Yeah. Now, actually, let me see one more. I'm copying this right. So that with absolute value. Okay, cool. 0, 1 x over square root 1 minus x squared dx plus limit. Then I think it's square root in it. Let me see. Just copy that. Limit sum cn. Okay. Limit. Sorry, absolute value. Sum n equals to, was it n equals to 1 to infinity cn, then x 2n plus 1. I'll check this here. Let me just write it first. What's x squared? Absolute value dx. Okay, let me just check that. That's the right hand side. Absolute value is n1. Yep. Dx. Perfect. Okay. And then immediately, right? The question tells me to replace this, or it tells me that I can let that be. So then I found this, haven't I? That's 1, isn't it? Yeah, that was the pink part that I found before when I did the recurrence. So that's 1 plus I'm going to replace this with sum n equals to 1, infinity of the limit of Cn times the limit of x to n plus 1 over root 1 minus x squared dx. Guys, I'm going to replace that with what they gave me, and I'm going to replace this with part 3. So you get 1 plus sum. That now, what is that? So that's like 1 times big fraction actually. 3 times 5 times 2n plus 1. Or 2n minus 1 rather. Okay. Okay. And then on the bottom you get 2n plus 1 to the power of n in factorial. And then that's green. Multiplied by pink, which I proved to be 2 power n factorial over 1 times 3 times 5 times. Now, just for working out purposes, I got 2n minus 1 and 2n plus 1. Right? That's important because I'm just going to move this in screen if that's okay. Okay, because now cancels. This whole thing cancels out with everything but the last bracket. That goes with that. Okay, so I just got this guy squared. Is that what I want? Yep. Then I got 1 plus sum n equals to 1 over 2n plus 1 squared. Now, if you look at the right-hand side, that looks exactly the same, with the only difference is that the 1's gone, and also n equals is 1 there. In the question here, you can see it here, right? It's 0. So what they've done is they've bolted the 1 into the limit, into the sum, right? So they did this. Because you know, for this expression here, right, when n equals 0, right, 1 over 2 times 0, oops, 2 times 0 plus 1 squared equals to 1. So therefore, by putting this into here, you sort of get equals to n0, 1 over 2n plus 1 squared. Perfect, which is right hand side. Okay, guys, that was a bit heavy, right? And that then leads me, so done part 4. Now we'll do part 5. Let's have a look. I'll go to the next slide. Sine inverse, okay, is that, okay, cool. So that's fact. And I've once again got this guy, right, that I can sub in to there potentially. Use this definition, show that, okay. Show that, so it feels like maybe I'll integrate both sides by 1, and then I'll use the expression, so from 1 to infinity. That's this one here. So let me see. Yep, I think I'll just integrate both sides, right? Yep, let me just have a look. Yep. Okay. 4, let me see. If I integrate both sides. If I integrate that. Okay. Maybe I'll divide everything and then integrate. Yeah. Divide, integrate, because like this guy's missing the square root piece right now. Because that looks exactly the same as that. Then that, yeah. You can see, right? And what I'm trying to compare is, see how this blue compared to this pink, right? There's 2 things missing, right? First thing missing is that this one all has square root of this guy on the bottom, right? So So it's missing from there and there. So I'm going to just divide everything maybe by that square root. And then the other piece that's missing is the integrals. And then I'll integrate that. And then hopefully that will give me, then I can use that right-hand side to do my question. I'm thinking, okay, yeah. So let's go there. So part 5. Yeah. So since sine inverse x equals to x plus sum n equals to 1 cn times x 2n plus 1, I'm going to divide all terms by root 1 minus x squared, divide that by root squared by this guy here, 1 minus x squared, and integrate, right? I'm going to maybe space this out a bit. So I can put my integrals in there. Like that. Okay. Because I'll do the green first and then do the blue, dx, dx, dx. Right, now that looks exactly the same as this, right? Pretty much. Yeah. So then I can conclude that, therefore, I'll do both sides, right? And then see if I can prove what I want. So this side, maybe I'll highlight this in pink, this side in pink. Right. That side in pink, and I'll highlight this side in green. For the green part, I'm just going to use, what's that? Reverse chain rule? Because the derivative of sine inverse is that. Right, so that's actually sine inverse squared, is it? Yep, like sine inverse squared plus 1. Right? So that equals a reverse chain rule, sine inverse of x squared on 2 with the limits of 1 and 0. And this one here would be the same as this guy. Right? Infinity n equals 0, 1 over 2n plus 1 squared, right? So this one here, just to be absolutely clear, right? That there, using part 4. Yeah, using part 4. Let's see what we get. So this one here, if I sub 1 in, sine inverse of 1 is pi on 2 squared on 2, and then 0 on 2, right? This side here, I think I'm just going to expand it, right? Let's see, 1, 3, 5, yeah, so they've just put in numbers. So they just expanded it. So they've basically said 0, sub in 0, that's like 1. Sub in 1, that's like 1 on 3 squared, 1 on 5 squared. The last one is, what's infinity, right? Dot, 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 is it? Yep. Well, they did one more, 1 on 7 squared, so I'm going to do that as well. And therefore, that's pi on 8, right? Pi squared on 8, perfect. 1 plus 1 on 3 squared, 5 squared, plus 1 on 7 squared. So pi squared on 8. Damn, guys, that was nice. So we're 10 marks in, got 2 more marks to clean this question up, finish it off. Let's have a look. Show that the sum equals that. Now, the sum has all the, it's not every odd, right? It's every second. So maybe I'll split it. Like maybe I'll pick the odds, and then maybe the other one, hopefully, I can get something out of it. So S equals 2. Maybe I'll bracket it. 1 plus, I'll do the odds first, right? Because then I can use plus, and then the evens, 2 squared plus 4 squared plus 6 squared plus. Okay, now this guy, looks exactly the same as this guy. So I'm gonna plug that in, I think. So freestyling a bit. So let me just check, make sure it's right. Yep. And then maybe for the second part, I know, factorize. Let's factorize, right? So sub in pi squared on 8 for the grade. And for this bit, maybe take out 1 on 2 squared. Is that what I should take out? No. Maybe. Maybe I do. Maybe I do, but I just got to figure out what that is. So that's like 1 on 2 squared plus 2 squared times 2 squared, right? That's 4. That's like 1 on 2 squared times 3 squared. So when I do factorize it, I sort of get like, oh, I'm at the bottom. Okay. Let's move it up. Yep. So then now, if I factorize 1 on 2 squared out, I get 1 plus 1 on 2 squared plus 1 on 3 squared plus, okay. Hey, that is what S is, right? Yeah, because S is basically when there's no, it doesn't jump odd or even, there's all of them. So then I can go and, oh, sorry, that's 8. Do a bit of recurrence, right? That's like 1 on 4 times S, therefore S, and then basically make S a subject, and I'm done, hopefully. Right, let's have a look. I'm excited. There it is. So 3/4 S equals to pi squared on 8. Therefore, S equals to times 4 up on 2. So pi squared on 6, is it? Guys, that, I mean, was a bit intense at times, right? Yeah, but that's how you do it. Yeah. This question here is all about, telling a story. It's a 12-mark story, right? Each step sort of relies on the step before. Really nice question. Final question, Sydney girls. Guys, hopefully you like that, right? Not too bad. I don't think so in the proofs topic in the Extension 2 syllabus. Guys, if you like that, subscribe to the channel, like the video, and tell your friends. I'll see you in the next one. Thank you very much.